That better? Hey, there we go. Okay. Good morning. Y'all ready to learn how to optimize your Linux for some gaming performance? All right. So before we get started, I'm sure all of you are wondering who this weird redheaded man up on stage is. My name is Thomas Castleman, and I am the lead developer and founder of Draugr OS, a Linux desktop gaming distribution based on Ubuntu. I'm an avid Linux gamer, so I play a lot of Doom Eternal, Doom 2016, Tomb Raider series, CSGO, what have you. And I'm also a maker, so I do a lot of 3D printing on Linux. I do some electrical engineering, not a lot, basic stuff, that sort of thing. And I also need to kind of set y'all's expectations, because as our more experienced people in the crowd will know, you can't get a Raspberry Pi to do 4K 120 FPS ray tracing. It ain't gonna happen, guys. So a lot of what you're gonna see works better on lower end systems. So think Chromebooks, older computers, that sort of thing. Some of them will show noticeable improvements on newer systems, and I'll point those out to you guys there later on in the presentation. Just know software can't fix everything. At some point, you just gotta pay up and get better hardware. And also, it is good to know that some of these fixes to improve performance or game compatibility at times may cause other problems in your system. Most of them won't, but occasionally you might run into them. So the first one is gonna be kind of controversial, I'm sure. A lot of people these days assume that you don't need swap, because if you have 16 gigs or more of RAM, then why do you need swap? For those who don't know, swap is basically where you take a bit of storage on your local hard drive and you use it as a bit of system memory. So let's say you have 8 gigs of RAM, you want to expand that to 16, 8 gigs of your internal storage would be used for swap. We do this because even though your internal storage is slower, what we can do is take things in memory that aren't needed right this second and move it into that swap area. Using swap, you can also get a couple new features. I use new very liberally here. Hibernate and hybrid sleep. I'm sure all of you are aware of sleep mode on your computer. It's basically where you put your computer into a low power state, still draws battery, but when you open it up, you can get right back to work. Hibernate is very similar, but it's saving what you're doing to your internal drive and actually shuts the computer off. Hybrid sleep is the best of both worlds. It saves what you're doing to both the hard drive and keeps it in RAM, and then puts your computer in that low power state. That way, let's say you have a laptop, if you lose battery power, you keep all the stuff that you're doing, it just takes longer to boot up. Of course, the less you have of RAM, the more you need swap. So, if you have like 4 gigs of RAM, you really need swap. It can be a file or a partition, so if you don't have this option presented to you when you install your Linux distro, you can set it up yourself after the fact. It's not hard. Now, these are sort of minimum amounts of RAM that I recommend. If you have 16 gigs or more of RAM, then half a gig of swap is plenty. It'll at least make your system more responsive. If you have 8 gigs, just 1 gig of swap will be fine. You at least want to have some so that your system can be more responsive. And then going down, the less RAM you have, the more swap you should probably have to compensate. Y'all didn't know you would be doing math today, did you? It's pretty simple, though, thankfully, because of the way computers work and are set up. So this is entirely in gigabytes. So if you have 4 gigs of RAM, you just take the square root of that, gives you 2 gigs. 4 plus 2 is 6, obviously, so 6 gigs of swap. This is the equation you need to follow if you want to enable hybrid sleep. If you just want hibernate, then as long as you have the same amount of swap as you do RAM, you're fine. Obviously, this means that if you don't have a lot of storage space and you want hybrid sleep, it's going to take up a lot of your storage space. So It's up to you what your priority is. The next thing that you can tweak is swappiness. This is a little bit more of a technical thing. So your kernel has a little algorithm in it that determines how readily things in RAM will get moved into swap. And there's a number that you can tweak that changes how readily your kernel will move things around. If you don't want it to use swap at all, but you don't have swap, or you have swap you don't want it used, you can set your swappiness to 0. It won't swap things out at all. And the higher you set your swappiness, the more likely it's going to use it. If you're using an Ubuntu-based distro, normally this is set to 60 by default. And of course, once you do this, it requires a reboot, but doing this change, it is persistent. So I'm actually going to demonstrate how you do this real quick. So this is a virtual machine running a live session of Draugr OS. So we're just going to open up a terminal real quick, and I'm going to blow that up for y'all so y'all can see it a little bit easier. And the file that we want to edit is in etc, and it is named sysctl.conf. All right, you're going to see a lot of stuff in here that's commented out, and we just got to go down here to the bottom and add it in. As you can see, by default on Draugr OS, it's changed to 25, so it will be a little bit less likely to use swap, so it'll keep things in RAM. All you got to do is just change this little number here at the end to whatever you want it to be. I don't recommend setting to anything less than 10, but if you don't want it to use swap, you can. There we go. All right. The next thing up is a little application some of you may have heard of called preload. What this does is it preloads assets, libraries, game files, etc. into memory. That way they will load up faster. Because if it's already in memory when the application requests it, it doesn't need to go out to the hard drive in order to read that data. It's already there in memory, so we can just go ahead and start working on it. The first time you use preload, it will actually make your computer slower. The reason for this is because preload intelligently learns what you load by default over time. So it's got to take some time to learn. But once it does learn, you will see things like apps launching faster, games launching faster, levels loading faster. Occasionally, you might even see your desktop itself loading faster, just because your preload has learned what it is that you need ahead of time and starts loading things up. If I'm not mistaken, this does require systemd, so if you're not running a systemd distro, then you may not be able to use this. Your mileage may vary. But the command there to install it on Debian-based distros is on the top line. All right. Some of you may have also heard of Failactive's game mode. This comes by default, I believe, on Garuda and a few other distros. What this does is it changes the game's CPU affinity, which is basically a way that it communicates to the kernel that, hey, this game is very important to me. I want you to allocate more time to it over something else. It helps reduce system latency, so if you really want to reduce your latency, it may help. And then that bottom line right there is what you would put in on Steam into the launch options if you want to use game mode. On Ubuntu-based distros, you can do sudo apt install game mode, and it should install it right there. If you're not running an Ubuntu-based distro, I'm not familiar with the command. I'm sure it's in the Arch AUR. If it's not, it's pretty easy to build from source. This next one actually works on any OS that you run, be it any Linux distro, Android, iOS, Windows, Mac OS, what have you. Just disable some system services. For instance, let's say that you have a computer that you literally never print anything from. You can disable the print service in the background. It's going to save you just a little bit of CPU time and just a little bit of memory. Now, disabling the printer service may not be a great idea, because if at some point you do need to print from it, well, you can't print now. But I'm not just talking about apps and services. I'm talking systemd services. I'm talking about shell scripts in the background. If you're running, for instance, XFCE like I am, or some other system service and you might have had GNOME, then you can go in and actually disable a lot of GNOME services that you don't need. Because GNOME actually has a lot of services that run in the background. This also can be done through XDG. So there's that. Next up is Proton GE. I'm assuming everyone in here is familiar with what Proton is. Proton GE is a custom version of Proton made by a wonderful developer named Glorious Eggroll. What it does is it's essentially, think of it, a development version of Proton, because a lot of the changes that he makes in Proton GE actually gets pulled into normal Proton. So you're able to try things like fixes for specific games, performance improvements, bug fixes, etc. early. Now, you can find the repository for this on GitHub, and you can install it manually if you so choose. But we can make your life a lot easier by providing a little tool that will install it for you. And that is Proton Up. I actually know the developer for Proton Up, great guy. He spent a lot of time on this. Proton Up itself is available through pip, which is the Python package manager. It is a command line only utility. So, let's say you want a GUI. Proton Up Qt is a Qt front end to Proton Up. And it not only provides a way to install Proton GE, it also provides a way to install Proton TK, Lux Torpeda, and several others. It's very easy to use. It's very fast, both Proton Up and Proton Up Qt. And they're both very reliable. They work on just about any distro I've come across. And if I'm not mistaken, Proton Up also provides a library for you to use if you want to develop an application yourself that hooks into Proton Up. This one's a pretty common one to find on, for instance, YouTube or things like that when you're looking to find ways to improve different distros for gaming, and that's updating Mesa and Vulkan. If you're running something like Arch, OpenSUSE, Solus, that is a rolling release, you don't need to do this. This is also true on Draugr OS. Now, if you're on a distro with slow release cycles, Debian, sorry, then this is essential. And I've actually listed here a couple good PPAs that you can try out. Now, I strongly suggest that you're very careful when you do this. The reason for this is because a few years ago on Draugr OS, we were using bleeding edge Mesa and Vulkan built directly from the repositories. This was the OIBAF PPA, if anybody is familiar with that. It worked great. It was providing terrific performance. And then one day, all of a sudden, everybody with an AMD or Intel GPU had no graphical output whatsoever. So be very careful with this. So that's, if you want the best performance possible, if you want the latest fixes, the latest features, everything as soon as possible, and you're willing to jump through those hoops and deal with that instability, that bleeding edge PPA right there on the top line, that's what you need. Now, if you still want better performance, if you still want new features, if you still want fixes, but you want it to be more stable, then that bottom line, the Keysock Turtle PPA, that right there will get you the stability and better performance. This is terrific because not only does this provide better performance, but this is also part of your graphics driver if you have an AMD or Intel GPU. Also, this can improve performance to an extent on Nvidia systems. And speaking of Nvidia systems, of course, update the Nvidia drivers. This one is pretty self-explanatory, so I'm not going to go into it too much. But this can enable new features like ray tracing and DLSS, which, lo and behold, are actually available now on Linux. I'm not going to go into it, like I said, because this is different on every single distro, and as I'm sure the entire Linux community is aware, the Nvidia drivers are a pain in the butt. I will say if you're running Pop! OS or Draugr OS, this is actually very, very easy to do. On Draugr OS, we actually have a package called Nvidia Driver Latest, which is a meta package that pulls down the latest Nvidia driver for you. It won't auto-update it. It will just let you know there is a new Nvidia driver available, and is pretty easy to just push through, get that new Nvidia driver, you're good to go. Pipewire is the new hotness in the Linux community. It can reduce your audio latency, it can spoof pulse audio and jack, so if you're using things that rely on pulse audio, then you can still use Pipewire. If you're an audiophile, I do not advise it to be used, because I've got some friends who are Linux users and are audiophiles, or musicians, and they've tried Pipewire and had it spoof jack, and it's not quite there yet. But it can also improve audio quality. For instance, so personal story, I love Doom Eternal, and took a while to get it running on Linux. Had to use Proton GE, shout out to Glorious Eggroll. That got it running, but I had this weird issue with audio crackling and static in the background, and it was really, really distracting. So when I switched to Pipewire, I didn't expect this, but apparently Proton actually hooks directly into Pipewire. And just by switching to Pipewire, it got rid of that crackling and static in the background of Doom Eternal. So that is what Pipewire can do for you. Now, Pipewire is great, but if you're familiar with the Mycroft personal assistant, or if you use any apps that hook directly into ALSA, which is what sits below Jack and Pulse Audio and Pipewire, it can have some issues, because apparently Pipewire is a little bit possessive of ALSA, apparently. Talk about a toxic relationship. So what will happen is when something tries to connect to ALSA, Pipewire will realize what's going on, and once that application disconnects from ALSA, Pipewire will not only reconnect to ALSA, it will also obtain an exclusive connection, so nothing can connect to ALSA from that point. There's a pretty easy fix, though. This command right here, that's actually all one line, it just doesn't fit on the screen. What it will do is it will create a file in your home directory. And what that file will do is it will tell anything that's trying to connect directly to ALSA, except for Pipewire, hey, don't connect to ALSA, connect to Pulse Audio. And then if you're using Pipewire, and it's spoofing Pulse Audio, instead of whatever is trying to connect to ALSA connecting to Pulse Audio, it connects to Pipewire. So just having this one little file in your home directory will fix that, and it doesn't even require a reboot, it just immediately starts working right away. This is actually fantastic if you're wanting to use Mycroft. I think Mycroft has kind of gotten it taken care of at this point because they're using a different audio backend, but it can be useful for a lot of other situations. All right, the next really controversial thing. Desktop environments and window managers. So for those of you who aren't aware what DEs and WMs, desktop environments and window managers are, this is the graphical environment that you use on your computer. Some of them are better than others, obviously. Just going ahead and laying down the law, don't use GNOME. GNOME is fantastic for touchscreens, don't get me wrong. I was setting up a Pine Tab 2 the other day. I was trying to switch to GNOME because it's that good with touchscreens. But it's a little heavy still. It's gotten better in past years, but it's still not quite there. So of course, a lighter desktop environment will be better. Window managers in general will typically be lighter than a desktop environment. So because of that, we can just say across the board, most window managers are okay. Yes, some are lighter than others, but we're talking about 10 or 20 megs of memory used versus 100, 200, 500 megs, a gigabyte, depending on if you're using GNOME or not. So in order of sort of lightest to heaviest that I would recommend, LXQT is fantastic. I don't suggest LXDE anymore because the developers of LXDE actually dropped support for that. And it's not being developed anymore. They've switched to LXQT. LXQT, if I'm not mistaken, is just a little bit heavier, but it's still fantastic. But it's also under development, and you don't get a lot of the creature comforts that you do with these other two. The other one is XFCE. That's what I personally use. It's highly configurable, very user-friendly, but it's slow to update. But if that's your jam, it's fantastic. And then I feel like this is blasphemy because a couple years ago I wouldn't be saying this. KDE is sometimes very lightweight, actually. It's also highly configurable. It gets frequent updates. It actually has Wayland support, although that is unstable, and we're going to talk a little bit about Wayland later. But KDE, when it comes to configuring how things look, in my experience, isn't the most user-friendly. If you want something that looks similar to Mac OS or Windows, KDE is a great choice. And then for window managers, what I just put up on there are just 3 that came to mind really quickly. A friend of mine who's actually doing a presentation tomorrow, Amalith, I remember him using i3. I've seen a lot of people on r/Unix porn using Xmonad, and then Spectre WM is one that I've used. And like I said, any plain window manager would likely be fine because they're almost unanimously lighter than the lightest desktop environment. Okay, before I get into this, do not do this unless you absolutely understand what you are doing, okay? Because if you don't understand what this is, then you could very seriously make it so that your computer is insecure. Also, if you have a computer that is using an AMD Ryzen processor or an Intel 10th gen CPU or an ARM CPU, there is literally no point in doing this. You will get no performance benefit, maybe 1 or 2%, not much. However, that being the case, if you have an AMD CPU that is pre-Ryzen or an Intel 9th gen and older, you can see performance uplifts of about 25%. And depending on your workload, it could be up to as much as 90%. That being said, because of the security implications of this, I don't suggest doing this unless you have an Intel 8th or 9th gen processor, because it has fixes built into the processor at the silicon level and in the microcode that will already mitigate some of these speculative bypass issues and not reduce your performance too much. 8th or 9th gen processors, though, they don't have all of them, so you can still get some performance improvement, but you're also not giving up that security. And all you really have to do in order to do this, the easiest way is in your bootloader, if you add into your kernel command line, mitigations equals off. Like I said, don't do this unless you actually understand what this is doing. Do not do this on a server. Do not do this unless you have, an Intel 8th or 9th gen processor. Newer, there's no point in doing this because you're not going to get a performance benefit. Older, you'll get a massive performance benefit, but you're going to be insecure, severely. All right. So some people like this stuff, some people don't. Enabling DSS or FSR or XESS, which are the sort of frame generation technologies for each of the major GPU vendors. DLSS is the one that performs the best on Nvidia, but it's not the best supported. You need to have an RTX 2000 series or greater in order to use this. You got to have a new enough kernel. You got to have a new enough Nvidia driver. and your game has to support it too. XeSS is only really usable on Intel dedicated graphics, which are very much in their infancy. So because of that, you're unlikely to be able to use this. FSR, however, is not only open source, but it also supports every single GPU vendor, whether that be Nvidia, AMD, Intel. Even if you're on ARM and using one of the ARM GPUs, it still works. And it's available out of the box on the Steam Deck. So in the Steam Deck settings, actually, if you go into the little right-hand panel, there's actually a little slider to change that. I'm not going to go too deeply into this, as this is most easily done in your game settings. And there is a way to enable this system-wide, but I have not found good, easy instructions on how to do that just yet. All right, we're going to start getting into the more technical stuff. You can use an alternate kernel. So, of course, using these can be a little bit of a hit or miss. That bottom link to the Arch Wiki provides links to even more alternative kernels and gives you a little bit of an explanation as to what a kernel is. If you don't know what the Linux kernel is, then I definitely suggest Googling it because I've talked a lot about it already. So that top one is Zen or Liquorix. So if you want to compile your own kernel, but you don't want to apply the patches in order to get it fixed, Zen is where you need to be. Liquorix is where you need to be, though, if you want performance improvements, but you don't want to compile it yourself. Liquorix and Zen are very much low latency kernels. I've used them for a very long time. They're fantastic. But ZanMod actually, in my experience, performs even better. I have been told, though, that ZanMod has a little bit of a security issue. I am not a kernel developer, so take that with a grain of salt, do your own research. But that is what I have been told, but it does perform very well. Now, of course, if you would rather be able to control how much your kernel can do and, you know, be on the latest kernel possible, there is another solution, but this is not for the faint of heart. Stereotypical compile your own kernel. It's actually surprisingly easy. If you're on Nvidia, you need to use the latest stable release. If you use anything newer, so an RC release, you're not going to be able to get your Nvidia driver's DKMS driver to build. If you're on AMD or Intel, you can experiment with those kernels, but I don't suggest using them unless you really see a huge performance improvement. And I'm actually going to demonstrate how you do this real quick. So if anybody wants the commands for this, then they're actually, I have them here, so, you know, not too hard. I've already cloned the GitHub repository, and I'm going to blow this up for y'all real quick. So this is my laptop right here. After you clone the Git repository, you need to use git checkout, and then choose the repo, or not the repo, the kernel that you want to use. Give me 1 second. Okay. Wheel. There we are. So that needs to be blown up too. There we go. All right. So I'm in my repository now to build it. So you can just use git checkout and then just put in the kernel version you want. So I'm going to do the latest kernel, so 6.3.5. There might be 6.3.6. It usually takes it just a second. Okay, so I'm on 6.3.6 now. Now, what I need to do next is switch to the other tab. There we go. All right, what I need to do next is I need to grab a kernel configuration. Now, if you're on an Ubuntu-based distro, this is actually really easy. If you look in your boot folder, you will see, I'm actually going to blow that up just a little bit more. There we go. You can see right there on the left that you already have some config files from the kernels that you're running. You can just copy those right over. If you're running an Arch-based distro, if you look in /proc, so ls proc, then in here you might find a config.gz file. And actually, we can filter that. Rep config. And I can't spell. Okay, so I did not enable this on the kernel I'm running right now, so we're not going to see that. So that's just a couple different places you can look. But what I'm going to do is I'm going to copy my latest config and let's see, yeah, 6.3.1 over to, boom, into the Linux folder, and you want to have it named .config. Boom, all right. So then from here, what we got to do is the configs aren't the same between different kernel versions. So next what we need to do is we need to adjust that config for the new kernel version. And that's actually very easy to do. You need make installed. This little j-j4 command, what it's going to do is it's going to tell the compiler to use multiple processor cores. So instead of just using one, it'll use 4, which will make this go much faster. And then menu config, and give it just 1 second. Okay, we got to shrink it down because I made it a little bit too big. Alrighty, so this is what you're going to end up with. I suggest going into general setup. You can change what you use to compress your kernel. I'm using XZ because it gives the best compression, but you can also use Z standard, which decompresses much faster. So I'm just going to stick with XZ, and you can change a bunch of different stuff. It's okay if you don't understand a lot of this. The preemption model. So I suggest using voluntary kernel. This makes it so that you can use preemption in your kernel, but you don't have to. If you use the preemptible kernel, it'll make a low latency kernel. So I'm going to leave it with the voluntary. And then there's a bunch of other stuff in here that you can tinker with. And then, let's see, processor type and features. There's a bunch of other stuff in here. In the processor family, if you don't know if you're going to use this kernel on multiple machines, or you know you are, you want to use generic x86-64. Beyond that, you can actually have it compile for specific x86 versions, and that might net you a little bit of a performance increase. So I'm going to stick with the generic for now. There's a bunch of other stuff in here. Performance monitoring, microcode, and there's a couple different things I'm looking for. Timer frequency. This is normally by default 250 hertz. You change it to 1000 hertz and it will net you just a little bit of a performance increase. And let's see. You can also go in and have it completely not even compile the speculative execution vulnerability mitigations. Again, I don't suggest doing this. There are some in here that you can disable, and it won't lose you a lot of security. So you can definitely tinker with disabling those. I've already done that here. There's a bunch of other stuff in here. Normally, I suggest just tinkering or just leaving it with what you have for now. I would definitely suggest going into device drivers, though. Going through here, and if you see hardware in here that is supported that you do not have, disable it. If you're not sure, leave it, or compile it as a module. The reason we want to do this is kernel modules that are actually compiled as modules, not compiled into the kernel, they do not load unless they are needed. So that way, until they're needed, they're not taking up any CPU resources, they're not taking up any memory. But any drivers that are compiled in by default are going to take up CPU time and memory and disk space. So if we just don't compile them, they won't even be shipped. So you don't have them taking up memory, you don't have them taking up CPU time, you don't have them taking up disk space. So if you're a distro maintainer like I am, disabling these can actually make for a quicker update. It can take your kernel size from about 70 or 80 megabytes down to about 50 or even less. I've already done that though, so I'm going to leave it. You definitely want to make sure that in file systems you support ext2, 3, and 4, and if you scroll down quite a bit, Btrfs, because those seem to be the most commonly used file systems in the Linux community. You can enable any that you use in there as well, but all you got to do at this point is just click Save, OK, and then exit. And then all we got to do is make -J and then tell it how many CPU cores you want to use. I'm going to use 4 because I'm still using the presentation, so don't want it to bog down my computer too much. This is where we can make our lives a lot easier. If you're using a Debian-based distro, if you do bin deb-pkg, what it will do is it will give you 3 deb packages. One for your kernel image, one for your header, and one for a new Linux libc. If you are on an RPM-based distro like Fedora or OpenSUSE, you can do bin rpm-package, and it should give you the corresponding RPM packages. If you are on Arch, if you go to the Arch wiki, there is actually instructions on what to do on Arch. Because if I'm not mistaken, there isn't a command to compile to a Pacman package. But I'm on Draugr OS, which is based on Ubuntu, so I'm going to compile a deb package, just hit enter, and let it rip. In my experience, this can take, depending on how many CPU cores you have, anywhere from about 30 minutes or so down to about a minute. My desktop at home, I have 16 cores, 32 threads, takes only about a minute or two. This laptop right here, I have 4 cores, 8 threads. It'll likely take the remainder of this presentation and then some. I was actually intending to SSH into my computer at home, but apparently it's not online. Technology, you gotta love it, right? And as you might hear, my fans are now whirring up because it's now compiling a bunch of code. So I'm sure a lot of you are now wondering, hello there. There we go. What about Wayland? All right, here's the thing, guys. Wayland is fantastic. Don't get me wrong. However, Wayland isn't quite ready yet, unfortunately. The only desktop environments that support Wayland right now are KDE and GNOME. Mate is developing support for it. XFCE is just starting development for it, but it's not quite there yet. And all the others either haven't started it yet or they're working on it, but it's not that far along. Cosmic, if I'm not mistaken, so they asked if Cosmic has support for it. Cosmic is not out yet. It should be coming here in the next year or two. So we don't really know whether or not it's going to have support for Wayland. I believe it is supposed to, though. Okay, so that would be good. He said their toolkits are Wayland. So you can use KDE with Wayland. I've done it before. The problem is it's not stable. You'll have a lot of crashes. Thankfully, the KDE devs know about this, and they're already working on it. And right now, there's a little bit of a workaround where if KDE crashes while you're using Wayland, it'll automatically restart itself. The downside to this is that means if you want to use Wayland, you have one real option, GNOME. And we've already established that GNOME is not the greatest for gaming performance. This is likely to change the next few years, but even Valve is aware of this. On the Steam Deck, when you're in game mode, it's using Wayland, but that's using the game scope window manager, which is designed with Wayland in mind. However, when you switch to desktop mode and you're using KDE Plasma, it's not using Wayland anymore. That's why you have to log out and log back in. It's because it closes down Wayland and starts up X11. And that's because Valve is well aware that KDE just doesn't have good stability with Wayland right now. Now, if you want to give Wayland a try, I have a few suggestions. First off, don't try to switch to it yourself unless you really know what you're doing. It's a lot of work in order to do that switchover on an already installed machine. It's a lot better if what you do is you either dual boot and let your distro maintainers take care of the whole Wayland switch, or if you just try it in a virtual machine. Also, don't bother with it yet if you're on Nvidia. And Wayland does have support for Nvidia, or should I say it's the other way around, because they finally added support for both, in both the Nvidia driver and Wayland. But the problem with it is you don't get any meaningful performance improvement by using Wayland on Nvidia. In fact, it's quite the opposite. You lose performance. You can use the proprietary Nvidia driver with it, which will get you some performance back versus the NoView driver, but it's still not great. Your other option, of course, is AMD and Intel. Those actually do have great support with Intel, or not. I can't speak today. They do have great support for Wayland. So if you are running an AMD or Intel GPU, you can definitely give Wayland a try, but like I said, you're going to be stuck with GNOME, so your mileage may vary. If you give it just a couple years, it should be significantly better. Okay, we have about 15, 20 minutes left, so does anybody have any questions? Yes, sir, in the back. Mike.
Thank you. Yeah, so when you're talking about Wayland, you were sort of focusing only on the desktop environments. Mm-hmm. What is your opinion on gaming on Wayland window managers like Sway or LeftWM or something like that?
So the window manager, so he asked what my opinion is on Wayland with window managers. The window manager space with Wayland is actually a lot better. If you run a straight window manager and you want to use Wayland, it's definitely worth giving it a try if you have an Intel or AMD GPU. The fact remains, though, that if you're running Nvidia, there's no real point in trying it. You're not going to get a performance improvement. Does anybody else have a question? Yes, sir.
So once your compile is done, then what? And I would want to load the new OS, the new kernel onto a separate partition.
So the question was, once you're done compiling the kernel, what do you do then? So the way I'm doing it is going to give me 3 deb packages. It's going to place them in the parent folder of my GitHub repository, right? What I can do is, I'm sure it's not done compiling just yet. Yeah, no, it's not. But what I can do is, and I'll actually switch to here. What I can do is sudo apt install and then just give the file path to them. And what that will do is it will tell apt, hey, I want to install these packages. If there's any new dependencies, go ahead and pull those down. And it also can tell based on that / that I'm talking about it's in a file, right? So it doesn't try to pull anything down unless it's a dependency. So that's what you do from there. You don't need to install it on another partition or anything like that. You can if you so desire. But what the repository I cloned is mainline Linux kernel. So I have made literally no patches. So because this is entirely open source code, vetted by the Linux community, I can rest easy that it is secure and stable and reliable. So I'm not too worried about it as far as a security standpoint. So that's really all you need to do. The command varies depending on whether you're running an RPM-based distro. You can also do, instead of sudo apt install /, you can do sudo dpackage, and then I believe it's -i, and then you give it a file path. But I normally suggest doing the sudo apt install because it pulls down the dependencies. There is another command that you can use that it doesn't build the packages. It actually just creates the kernel image, the modules, and all that, and then it just installs them directly on your computer. I don't suggest doing that, though, because when you go to want to remove that kernel, you will have to manually track down everywhere that kernel is installed to, which means you're going to have to dig around in your computer, and if you're not careful, you can very easily delete something that you shouldn't. Believe me, I have done it before numerous times. But that's how we learn. So yeah, you just sudo apt install and then reboot. That easy. Is there any other questions? Yes, sir.
Yeah, so if you have 16 or 32 gigs RAM and you're not maxing out, what's the point in having half of a gig of swap space? You said responsiveness, but isn't disk always slower?
So the question was, if you have 16 gigs or 32 gigs of RAM and you're not even maxing it out, what is the point of having half a gig of swap? Yes, it is the responsiveness. Yes, the disk is slower. The reason you still want the swap is because what your kernel is going to do is anything that you're not using actively, it is going to move to swap. Now, it won't do this unless it has to. So what you will see being moved out is things in your file system that is caching that it might need, but it doesn't need soon. So if you have that much RAM and you're not using it, really all it's going to end up doing is just making your system more responsive. And that's why I'm suggesting only half a gig of RAM. Half a gig of RAM is something that most people can accommodate. It's not going to get in the way of your system for the most part. You can definitely do less swap if you want to, 100 megs. I just suggest that half a gig. That way, if at some point you're doing something like running a virtual machine and a browser at the same time, browsers these days use a lot of RAM, so it's very possible at that point you could just run a little bit over. It'll keep your computer from crashing in a case like that. So it not only makes your system more responsive, it also gives you just a little bit more stability and reliability. That's why you'll find a lot on virtual machines like on a VPS or on servers, they still have swap even if they have like 100 gigs or more of RAM. It's just a stability and reliability thing. Any other questions?
So am I safe to assume, if I know I'm going to be running Linux, so I'm running Linux exclusively, to just get an AMD CPU because it'll make my life easier?
So that's a great question. So the question was, if I'm running just straight Linux, I probably need to get an AMD CPU, correct? Okay. In a nutshell, yes. So currently, if you were to get a newer Intel CPU, they're doing something similar to what ARM does, where some of your CPU cores can't clock as high, and some of your other CPUs can clock higher. That's great for power efficiency, but if we're wanting strictly performance, then the CPU scheduler on Linux is just now getting good support for those Intel processors. You would think it would be easier because Linux runs on ARM all the time. I mean, who here has an Android device? It's running Linux right now. Yes, it's not a normal Linux desktop, but it's still the Linux kernel underneath that we're talking about. So you would think that it would be fine, but there's some notable differences you have to take into account. And because Linux was actually initially developed for a 386 clone, because it's been initially on x86 and x86-like CPU architectures since its beginning, it's had a lot more time to mature those CPU schedulers. So because of that big little architecture, CPU scheduler doesn't perform quite as well. And from a security standpoint, AMD CPUs are already more secure because we keep finding more and more speculative bypass vulnerabilities in Intel. AMD does have them. They are vulnerable to Spectre 1 and 2, but just not as vulnerable as Intel is. So if you want the security and the performance, your best option is to go AMD. That is not to say that you won't get good performance on Intel. It's just AMD is a little bit more reliable on Linux right now, to the point where Intel actually develops their own Linux distro called Clear Linux. If you want the maximum performance possible without having to do basically anything, just install that distro. But it's their own custom thing, custom package manager and everything. That is the way you get the best performance on Intel. If you want the best performance possible on AMD, you just install Clear Linux on AMD. And it actually performs better than it does on Intel. Yeah, right? Are there any other questions? Going once. Yes, sir.
So that glorious egg roll GUI, is that GUI in Steam, or is there some other thing?
It's a great question. So he was asking about Proton QT. Is that in Steam or in something else? Proton QT is its own little thing outside of Steam. It is actually able to install Proton GE both into Steam and into Lutris and into Heroic if you use that. It just gives you a central UI to control all of your Proton GE, Proton TK installations across your entire system. So it's its own thing, but it hooks into everything. Any other questions? Going once. Going twice. Sold to the Red Hat. Alrighty. And with that, I'm going to let y'all go early. Thank you for coming. If you have any questions about Draugr OS or about compiling your own kernel or anything, feel free to hit me up. I'll be up here for a little bit longer answering questions. Thank you very much.
And, oh, thank you. Do you want me to say in there? Sure. Oh, well, it's just for future stuff, so I'm not going to show that. And one of the things they talk about is loading. There's like a firmware loader, and that can improve performance. And there's also a different way to configure the kernel using incursion instead of the make config, make in config. Gotcha. Yeah, and that one not only looks cooler, which has like transparency and all that kind of cool stuff. You can also search for like config options and like the symbol. Right there.
So
echoes of
you
orange.
can actually search for the config options in the menu config as well.
Yeah.
And there's also a GUI configurator.
Yes.
I just don't use those because I've had historically really bad time actually using this.
Yeah, I've had really bad times with does it make X config or whatever it is?
That's for the specifically X11 one, but there's also one for